Charles Cowart, FTT 111, Firearms Inspection and Troubleshooting, Week 8, Fastener Repair Lab, 28 October 2024. So here's a real quick summary of all the tools we'll be using for this Fastener Repair Lab. I've got Tap Magic for aluminum. It's basically cutting fluid to help in the drilling and tapping process. I've got blue die chem here, and that'll be for getting this marked to where we can basically mark our measurements. Permablue here, provided by the school, that's going to be for refinishing one of the screws that we have to repair. You've got your tap handle, center punch, a properly sized Phillister screwdriver, an improperly sized screwdriver that'll be used for marring one of the screws that we'll eventually repair. We have calipers, a piece of paper, a pen to do all of our measurements, and some 320 grit sandpaper as part of the repairing process for the screw. We'll probably wind up also using a needle file to repair the screw. And then the bits provided, we have the center bit, the number 31 jobber bit, the 648 tap, the 648 Phillister screws, 5/64 jobber bit, and finally our spiral flute screw extractor. So the first thing we're going to do is put this die chem on here to where we can see where we scribe our measurements to get our center for our 3 holes that we're going to wind up drilling. This stuff is really nasty. It'll get on anything and stain real easily, so I'm wearing gloves, and I put some shop towels down to prevent it from getting on my mat. Okay, we're gonna let that dry. And if we need to put any more to get good coverage, we will. Otherwise, once it's dry, we'll go ahead and do our measurements and get our scribing done to find the 3 spots that we're gonna put our screws into. So the die chem is dried, and I went ahead using my calipers. I measured the length and the width of this thing. The length was 4.5 inches, and then you divide that by 2. That gives you your center line here, and then you divide that by 2 to get your 2 offset screws, off-center screws. And then the width, that was the length, and then the width, it was 2.057 inches. You divide that by 2, and that gives you your long axis center line, which was 1.025 inches. And then all you do is you set your calipers to exactly the size you need, and you just scrape the line across that die chem, and it gives you a good clear line to start with. Next thing I'm going to do is, using a center punch, I'm going to go ahead and get a good starting point for my drill. So all we're going to be doing is getting a good mark. And there you go. You can see the little points that the center punch made. Now we can start drilling. So next we're going to go ahead and use our center bit to get these holes started, and safety glasses are on. This also has a shield, and I've got the nice little crosshair lasers to help me assist this. I'm going to go ahead and make sure everything's centered, it's not wobbling, and we're going to go ahead and get to drilling. Now using the number 31 jobber bit with a little bit of the tap magic, we're going to get these holes completely drilled. The holes are drilled now, and now I just need to go ahead and tap them using this tap. It's the 6 48 tap. So here are the drilled and tapped holes. As we can see, that one's pretty rough. I still went ahead and tapped it, and the screw's still screwing it, but it was not great. But these other two holes came out perfectly. So here the 3 screws are installed. Right there. I got a little bit ahead of myself and I boogered this one up with the too small of a screwdriver. So I'm gonna have to repair that as the project requires. I'm gonna go ahead and I'll screw this one in a little bit cross-threaded, and this one I'll go ahead and I'll cut the tip off of that because that hole's pretty messed up anyways. It's probably not the best one to do anything but that with. So I'll just... Okay, so here's our boogered up fasteners. This one, as you can see, has been cross-threaded. This one, the tip's been marred up a little bit from using the wrong size screwdriver. And here we have a broken head. So here's our screw that we've used a needle file to repair. All the burring's gone. All that's left to do is re-blue it and then reinstall it. So now we're going to go ahead and get into the re-bluing process for this screw. Basically, we're just putting this this Permablue on here. We'll be putting it on a cotton swab here that we've already scuffed this and degreased it, prepped it. So we're going to put the first coat of this on, and they say wait 1 minute and then rinse with cold water. So here is the screw. It has been re-blued and it's pretty much the same as the other screws. Took about 4 applications for me to get it there. And here we go. There is the completely redone screw, and it is installed. I will say that I did have to use a slightly larger screwdriver to get the proper fit after refitting this screw. Okay, so next we're dealing with this cross-threaded screw. So we're going to go ahead and get it out, and we'll re-tap, then see if it'll screw back in. Okay, we're going to apply a little bit of tap fluid to the hole, and also to our tool, and we're going to go ahead and re-tap this and see if we can get this to work. I've got terribly shaky hands, so I actually have to use the screwdriver all the time, otherwise I'll cross-thread it. To be going in, no issues. And there you go. It fits in perfectly. Last thing I'm going to be doing is cleaning this up where this head broke off. And then I'm going to use the center punch to make an indentation. I'll be using this 5/64 jobber bit to drill a hole where I made that indentation. And then using this spiral flute screw extractor to remove that screw. And then we'll see what the condition of the threads are. If I have to retap it, I'll retap it. Okay, I filed that down, and now I'm going to go ahead and make a mark right in the center there. Next, we'll be using this 5/64 jobber bit to get a pilot hole. So I have a problem. That screw is not coming out no matter what I do. I filed everything down nice and smooth, marked the center, drilled it, and then tried to get the extractor in there. Basically, the extractor is just not biting it at all, and so it stuck. I really don't know what to do from here. So overall, I would say I enjoyed most of this project, but that screw extraction, I really feel that if you have absolutely zero experience working with taps, extractors, jobber bits, all that, it's probably not the best format to do simply online. That was it. FTT 111 Fastener Repair Lab.